Welcome to video 11 on conservation principles and systems. And the essential question we're trying to answer today is, how can I use open and closed systems to track the flow of conserved variables over time? So the word conservation means to keep the same amount of something over a period of time. When we refer to the principles of conservation, what we mean is that, as far as physicists can tell, there are 6 variables that are always conserved in our universe. And this means that they cannot be created or destroyed. The 4 of these that we're going to focus on in this class are mass, momentum, energy, and charge. So the amounts of these things in our universe today are always going to be the same. We cannot create or destroy any new mass. What we have is what we will have forever. One way that we can solve problems and keep track of these conserved variables is using a technique that we call systems. A system is a way of separating an object or objects from everything else surrounding it, and this helps us to analyze what's going on with a system. We draw boxes around things to indicate that they are part of a system, and we can draw a box around something simple like this block of wood, or around something more complex like this sports car. Everything included in the system is inside the box. One thing you'll notice here is that we can draw boxes with a solid line or a dashed line, and that tells us something else about that system. When we draw a system with a solid line around it, we call this a closed system, and we're assuming that the object inside is completely isolated from everything else around it. So if we have a closed system that contains, say, a birdhouse, we know that earlier in time, say 2 days ago, all the materials that were used to create that birdhouse must also have been in the system. So the mass of the birdhouse today would have to be the same as the amount of mass that the materials were made up of 2 days ago. In an open system, variables can move in and out of the system. We can also track the changes in each variable as they enter and exit the system. So let's say we have that car once again. Things that can come into this system. Well, people can enter this system. Gasoline, when you put gasoline into your car. Because you are adding to your system, you're having a positive change to maybe the mass or energy in that system. Now, as we drive that car, other things can actually leave our system. So some heat will be leaving our system. Gases are coming out of the tailpipe. We might be losing little bits of rubber along the road as the tires rub against the road. So these things would result in a negative change in various different variables, such as mass and thermal energy. So take a visit to revisit the essential question that we started with at the beginning of the video. How can I use open and closed systems to track the flow of conserved variables over time? And write 2 or 3 sentences summarizing what you've learned. You could talk about dashed and solid lines, open versus closed systems, and how we track variables in and out.